All right, last two questions. A channel flows from north to south at a rate of 15 miles per hour. Channel, like a river, narrow body of water. A sailboat heads at an angle of 30 degrees upstream at a rate of 40 miles per hour. And a strong wind blows towards the northwest at a rate of 30 miles per hour. So we've got three different vectors, three different quantities. We've got the current, the water, the sailboat, and the wind. All right. And so write each of the vectors for the current, the boat, and the wind in component form. So I'm going to use a C, a B, and a W for current, boat, and wind. All right, so the current flows from north to south at a rate of 15 miles per hour. I don't need trigonometry to do that, right? It's just over 0 down 15. Okay. The sailboat, however, heads at an angle of 30 degrees upstream. So here's the horizontal. Here's our 30 degrees. And we're going 40 miles per hour. So it must be using its engine. And so we've got the boat. And so we've got our magnitude times the cosine of 30 degrees. Magnitude times the sine of 30 degrees. I'll change that into decimals here in just a moment. And then we've got the wind. Excuse me. A strong wind blows towards the northwest. So northwest, right, here's north, here's west. So this is 45 degrees here. The direction is 135 degrees, like 180 minus 45. And its speed or its magnitude is 30 miles per hour. So we've got 30 times the cosine of 135, 30 times the sine of 135. All right. And you know what? I'm not even going to change all those to decimals. I'm going to just walk away, right? We did what we were supposed to do. Part B says find the resultant vector. Remember, that means the sum. We're going to add all these three things together. So I'm going to use S for sum. And this one I will go ahead and use my calculator. I'm going to add these three numbers and then I'll add these three numbers. So I'll just grab my calculator, making sure it's in degrees. 0 plus 40 cosine of 30 plus 30 cosine of 135 gives me a 13.428. And then we'll do our negative 15 plus 40 sine of 30 plus 30 sine of 135. And that gives me a 26.213. Okay. And you know, to be honest, I really should have drawn this picture like completely as to what's going on. So I'm going to draw it right here. So we've got this boat going like this, 40 miles per hour. We've got the current dragging it straight down, 15 miles per hour. And then we've got the wind blowing back this way at 30 miles per hour. So this red one has a length of 30. So we're going up and to the right, straight down, and then up and to the left. I'm looking for the resultant vector. Right, so we're definitely not using law of sines or cosines here because, well, look at that. It's a mess, it's not a triangle. So it makes sense, according to my picture, that both of these components are positive because from here we're going over and up, to the right and up. Okay. So part C says find the sailboat's true course and speed, right? This is what the sailboat was aiming for, but then those other two forces or quantities is kind of pushing it up and to the left. So find its true course and speed. So we're going over 13 and up 26. .428. I want to try to find the magnitude. I want to try to find the length. So the speed, right? These are both speeds. Is the square root of that number squared plus the other number squared. Pythagorean theorem. So I'm just going to go back to my calculator. I've got the square root of that 13 something number squared plus that, 26 number squared. And I get 29.452. And this is in miles per hour. And then we want to find the true course. And they didn't say bearing or direction, so we'll just label it as such. But we're going to find this angle right in here. So let's see. Theta equals the inverse tangent of that 26.213. Right? Tangent equals 26 over 13. So we have the inverse tangent. Inverse tangent of, I want the, I'm just grabbing those numbers, 26 point something divided by 13 point something. And inside that inverse tangent, that gave me a 62.876 degrees. And that's the direction of the sailboat. They didn't tell us to give it as a bearing, so I'm going to leave it as a direction. Okay. Good. So again, law of sines, law of cosines, not an option because we had 3 pieces of information. So then the sum then, gave us that 4th vector, and so we're not talking about a single triangle. Okay. All right, last one. It says a wagon is pulled by exerting 25 pounds on the handle, which makes an angle of 30 degrees with the ground. Okay, so we've got the ground, wagon, handle, 30 degrees. The force pulling on that wagon, 25 pounds. How much work is done moving the wagon 150 feet on horizontal ground? So here's our displacement vector, right? The movement. Here's our force vector. And we said that work is the dot product of force and displacement. Well, our displacement vector, that's the easy one, right? We need to go find our force vector. Well, we've got the magnitude and the direction, so let's see. We've got 25 times the cosine of 30 degrees and 25 times the sine of 30 degrees. And I could change those into decimals, and if, you know what, may as well, why not? That's okay. So I've got 25 times the cosine of 30 is 21.651. And then this will be 12.5, right? Sine of 30 is 1/2. So that vertical component is 12.5. So I want to find that dot product of these two, 21.651, comma, 12.5, and 150, comma, 0. So we're going to multiply that 21 by 150. So I'm going to go grab my calculator, multiply it by 150, and I get 3,247.595. And then when I multiply the 12 by 0, I get, what did I do? Yeah, no, that's right. Sorry. I will type on my calculator. 12 times 0 is 0, so we're adding 0. And so we get 3,247.595. foot-pounds, right? We talk about units for work would be foot-pounds.